You've probably heard the word neuron before. If you haven't, in this context, a neuron simply means a point that is used to either input, manipulate, or store data. The first layer of neurons are input neurons. The input neurons tell a neural network what is going on. Let's say our neural network is playing tic-tac-toe. Each of the input neurons coincides with the spot on the tic-tac-toe board. So when the tic-tac-toe board has data, the input neurons pass it to the neural network. The next layer of neurons are hidden neurons, but basically they just process data. Let's say our tic-tac-toe board looks like this. Any person knows to put an O here, but the network doesn't. So it creates a hidden neuron. The hidden neuron says that if there's an X here and an X there and nothing in this spot, then it should play an O in that spot. The final layer of neurons is output neurons. Once calculations have been done, it shows where the network plays. Now, a neural network doesn't just have one hidden neuron, it has multiple, which would look something like, well, this looks a lot more complex. It really isn't. It's the same process of inputs, calculations, and outputs. Let's say the network is put in this position, where it has to choose between blocking an opponent and winning the game. We as people know the answer. However, the network has decided that both of these options are equally valid. This is where weightings come in. Weightings tell the network which option is the most valuable. The weightings in tic-tac-toe from most valuable to least valuable are winning the game, stopping an opponent, gaining winning potential, or any other move. The neural network chooses whichever one of the possibilities has the highest weighting and plays it. So now in this situation, it knows that it should win the game. The network learns through a process called backpropagation, which can be summarized in a very specific way. Let's say we know that the network should put a no here. We do know this. And we tell the network that. We say, in this situation, with this data, we should put a no here. Not that the network is making this decision, but that we know it should. So we take this decision and we feed it back through the lines of nodes, making slight changes as we go. But the network isn't currently doing this, but if I would add a line, let's say here, asking if that node is empty, then it would start. For each data set you have, or in this case, tic-tac-toe board in which you know the correct move, you can backpropagate it through the network, making slight changes as you go. The more slight changes you make, the better your network becomes. While backpropagation is supervised because we know all the answers, there's another type of learning, unsupervised learning, in which we don't, and we simply feed the network data where we may not know that you have to put no here. This is a relatively simple neural network, but more complicated ones can have multiple layers of hidden nodes. Overall, I think neural networks are a very fascinating field of AI, and while this was just a brief overview of their structure, I hope it was helpful.